Hi students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some interesting problems on the chapter rotational motion. This is part 4 of the video. Kindly do watch the previous videos also. This is the first problem. Moment of inertia of a body comes into play in a linear motion, in motion along a curved path, in rotational motion, none of the above. What is meant by moment of inertia? Moment of inertia, I have given the definition here. The moment of inertia of any object is the measure of its ability to resist a change in its rotational state of motion. Okay. Hence, the moment of inertia comes into the picture only for the rotational motion of an object. Hope you understood. This is the right answer. C is the right answer in rotational motion. Hope you understood. Let us see the next problem. It is saying moment of inertia of a ring of mass m and radius r. This is, let us say, this is a ring which is kept in a horizontal plane like this. This is a ring. Okay, a ring of what? A ring of mass m and radius r. Okay, radius r about an axis passing through the center and perpendicular to the plane. Okay, this is the plane of the ring. Okay, perpendicular to the plane means this is like this. This is the axis which is passing through what? COM. Okay, this is called centroidal axis. Centroidal axis. Okay, this is inertia, okay, of the axis which is passing through what? COM, center of mass of the ring. Okay, I COM will be equal to what? M R square. That you have to remember. M R square. This is the axis which is passing through CM. This is called centroidal axis. M R square is the right answer and it is perpendicular to the plane. Okay, M R square is the right answer. Hope you understood this. Okay, we will go to the next problem. What it is saying, the moment of inertia of a straight thin rod of mass m and length L. Okay, mass m and length L is here. Okay, about an axis perpendicular to its length and passing through its one end. Now, this is a thin rod. Okay, now we know that this is thin rod of mass m. This is a rod of mass m and length L. Okay, mass m and length L. This is L by 2 and this is L by 2. Okay, this is the axis which is passing through center of mass. This is called centroidal axis. The formula for this one you have to remember 1 by 12 ml square. 1 by 12. What they are asking, you are supposed to calculate moment of inertia of a straight thin rod of mass m and length L about an axis perpendicular to its length and passing through its one end. One end means here. Okay, one end means here. This is corner. Okay, this corner. I corner you have to find out. I corner. I can write I corner by using parallel axis theorem. Okay, I corner. Okay, by using parallel axis theorem, I can write I com plus of what? What is the mass? Mass is m. Okay, mass of this thin rod is how much? M. Okay, m. What is the distance from this axis to this axis? The axis which is passing through center of mass and the axis which is passing through the corner. Okay, that is m L by 2 the whole square. How much is I com? That is 1 by 12 m L square plus of m L square by 4. Right. 12 1 ml square plus 3 ml square. I am taking 12 as LCM, that is 4 ml square by, that is 1 by 3 ml square. So I corner, okay, moment of inertia of corner for a thin rod of mass m at length L equal to 1 by 3 ml square. Kindly to remember, okay, ICOM, okay, ICOM is how much? 1 by 12 ml square, and I corner is equal to 1 by 3 for a thin rod. For a thin rod, 1 by 3 ml square. Thin rod. For a thin rod of mass m, and length L. And length L. Hope you understood. ICOM is how much? ICOM is 1 by 12 ml square. I corner is 1 by 3 ml square. Hope you have understood. 1 by 3 ml square is the right answer for this one. We will see the next problem. What is saying? 3 rods each of length L and mass m. Length L is given. Okay, mass m is placed along x, y and z axis in such a way that one end of each of the rod is at the origin. Okay, the moment of inertia of the system. Let us say this is x axis, this is y axis, and this is z axis. Okay, 3 rods. Okay, one rod is kept at what? 3 rods each of length L and mass are placed along okay, along x axis. Okay, this is one rod, and one rod is kept here, and one rod is kept here. Okay, these 2 rods are kept in the xy plane. Okay, this is, we're supposed to calculate the moment of inertia of the system about z axis. So how much? Iz will be equal to what? Ix plus Iy. Okay, that is equal to corner. What is the formula? Just now we have seen I corner, okay, is 1 by 3 ml square. No contribution of this one, okay, because this rod is lying along the z axis. Therefore, contribution of this one is not there. Iz is equal to what? If plus Iy. 1 by 3 ml square plus for x axis and for y axis 1 by 3 ml square. That is equal to 2 by 3 ml square. Hope you have understood this one. 2 by 3 ml square is the right answer. We will see the next problem. And this is the last problem for today's class. 3 point masses each of mass m are placed at the corners of an equilateral triangle of side A. Okay. This is an equilateral triangle. 3 point masses m, and n are kept. Okay, this is A, this is A, this is A. Okay, then the moment of inertia of the system about an axis passing along one side. Okay, along one side. One side means, okay, let us say this is A, this is B, and this is C. Okay, C. I am interested here. Okay, to find the moment of inertia. Okay, this is my axis of rotation. Axis of rotation. Okay, I am interested to find IAC. IAC is equal to, now what is the formula for I is equal to m into r square. Now the contribution of this mass and this mass will not be there because they are lying on the same axis of rotation. Where is the another mass? Another mass is here. Okay, at a distance of how much? At a distance of how much? Distance of, if this is A, and A, this is how much? This will be A by 2, right? And this will be A by 2, right? Because this whole distance is how much? A. Since this is equilateral triangle, all sides are, okay, equal, right? Now this is A by 2, A by 2. How to calculate this one? Let us say this is A already taken, this is B, and this is C. I will call this C. How to calculate BD? BD square will be equal to what? Which is hypotenuse? This is right angle triangle. This is a right angle triangle. A, B, D is a right angled triangle. Right, okay. The square on the hypotenuse is equal to sum of the squares on the other two sides. Therefore, AB square is the hypotenuse because it is opposite to what? Right angle. AB square is equal to what? AD square plus of BD square. Therefore, BD square is equal to what? AB square minus of AD square. Right. That is equal to BD is equal to square root of AB. AB is how much? A square minus of AD is how much? A by 2 the whole square. Okay. That is equal to, let's simplify here, BT will be equal to how much? Because I have to find the perpendicular distance from this axis to point B. BT is equal to what? Square root of A square minus of A square by 4. That is equal to square root of 4A square minus A square. That is equal to BT is equal to square root of 3A square by 4. That is equal to root of 3A by 2. Right, root of 3A by 2. Now what is IAC? IAC, you have to use the formula m into r the whole square. What is the point mass? M, small m is m. What is the distance? That is, what is BD? BD we got BD the whole square, correct? BD the whole square. That is the distance. So IAC is equal to what? M into, how much is BD? BD is root 3 A by 2 the whole square. That is equal to M into 3 A square by 4. That is equal to 3 by 4 M A square is the right answer. IAC. Okay. 3 by 4 M A square. Students, hope you understood these problems. Kindly share the video if you liked it with your friends. Subscribe for my channel. After subscribing, if you have any doubt in the problems, kindly comment in the comment box and like the video if you really liked it. I wish you all the best for your KCET, NEET and IIT JEE examinations. Thank you for watching.